Imagine you're building a house. You cannot directly start laying the bricks, right? First, you have to understand the requirement. Um, what are the rooms I need? Example, living room, bedroom, kitchen, right? How many floors I need to build? Where does the staircase comes? And what is the size of each room? And what comes besides what? For example, if you keep kitchen and the dining area too far from each other, every day there is difficulty in serving the food, right? If you keep a kitchen and bathroom together or nearby, the hygiene get affected, right? So these are the decisions that you have to make before you start building the house, right? Maybe this is your main door. This is your living area, and here is your bedroom. Mm, this is your kitchen. Okay, this is your bedroom too, right? So if you don't decide what is going to happen or what you are going to build in advance, if you build something wrong, it is very expensive to change it, right? If later you realize that, okay, I should not be putting the bedroom here, instead, I want it here. Okay? For some reason, you change your mind, right? Maybe you keep the bathroom here, right? Somewhere here near the kitchen, and later you realize that, okay, this is not hygienic, or I want to change this. So changing this will cost you a lot. You cannot just like demolish the walls and rebuild, right? That is a very expensive operation. So before you start building your house, you have to decide all of this. Then only you start the construction, right? So this the same applies to software architecture. Imagine a company is building a software product. Example, banking application. First, we have to understand why the product exists in the first place, right? Who is using the software? What is the use of this software application? Is it really needed? Is there any real problem statement that this product will serve? First, we need to understand that. Then, once we decide this is needed, then we have to understand who are using this, who is going to use, and if at all, if some people are using, what is the mode of access, and if we need to store some data, where are we going to store that data, right? So this all needs to be decided before you build anything. I'm just like explaining this with a simple example. There are a lot of other components that we need to take in consideration in real enterprise systems. But let us start with this simple example. Okay, there is user, there is your banking application, and this is your database. Okay. First thing, these all needs to be connected. User access the banking application, and you store user data in database, right? Without this, the banking system will not exist, right? The user and the database are supporting banking system. Now, when it comes to access this part, you have to decide what is the mode of access, right? How you are making this banking application accessible to this user. This is what you need to decide, right? And here, how you store. store user information, right? So this banking application needs to communicate with the database to store this user information, correct? So this has to communicate with banking application. Banking application has to communicate with database. Okay. Now three components involved here: user, banking application, and database. And if you start building banking application without deciding all of this, right? So what happens? You build something, okay? So banking application version 1, okay? You build something, you don't know how this user is going to access this, and you build in assumption that user is going to access in a way that is approach, okay, we'll call it user access approach 1, but later you will understand there are more users with approach 2. Okay, example, this is a web app users, there is mobile app users. Okay, you build in the intention that this banking application is used by web app users, but later you realize there is a requirement for mobile app users also. Now what you have to do, you have to go change this, okay, change this and make it available for mobile applications also. Okay, this is a costly operation, right? And database also, you store information in one format, maybe a simple like user details, user account details, right? Later you will understand that you want to store more information, maybe transaction history, right? Now you cannot keep on changing the banking application for every small requirement, right? So you have to decide what my banking application looks like before even you start coding. And this is the part that we have covered now is only applicable to the implementation details. There are a lot of other stakeholders that come into picture. Example, if tomorrow, today I'm building this application for maybe 10 users, okay, 10 users. Sorry for that. Yeah, 10 users. Later, if I want to make this application available for 1,000 users, I have to see if my product or application supports 1,000 users parallelly, right? Maybe next it is going to be 1 million users. Banking application, like in real enterprise, has many billions of users at a time, right? You have to take that also in consideration. And next thing that you would worry about is, um, okay, what this goes down, right? Goes down. So if this goes down, the user is affected. The user cannot access his banking application, can't see what is happening, right? This system should not go down. And you know, in real banking enterprise, we cannot afford to um, lose that system or go that system down, right? It has to be up always. And imagine the worst case when it happens in middle of the transaction, right? Even when there are small glitches, the a crowd will go panic. But imagine what the entire system goes down, right? So we also have to make sure that this system does not go down, right? This is one aspect. And the next aspect that maybe you're worried about is the cost of building this system, right? You should be able to use best optimal technologies, okay, platform and resources to make it cost effective. This also we have to keep in mind. So what we did, it was when we started, it was a simple banking application, right? It was just user, it was application, then database. Now, what all we have added here? Okay. We have added the user interface, right? Whether it is a web app, mobile app, have added scale, number of users, and database info, what all we are going to store, and cost, resource usage, right? So this is a simple application. We have approached it with four aspects. So now understand the complexity of enterprise application. Okay. Now, if you start building a enterprise application without making all these decisions, then what is the cost of changing it every time, right? So this is where we need software architecture. So what it does, software architecture is deciding what we are going to build even before we start building it. And the one who does all this design and plan is called the architect. Okay. With the example we discussed in the beginning, that the building application, right? When you are constructing a building, you decide all the requirements that you need to cover about the rooms, about the floors, the room locations, size of the rooms, your entry gateway, all that, right? The same thing needs to be done for software, right? Here you are deciding who is the user, how I'm going to store the data, what is the number of users I'm going to allow, how I'm designing so that it is cost effective, right? You're going to cover all these aspects. So, in nutshell, all of this is called as architecture. Okay? This is related to software and this is related to building. This is what is software architecture. In upcoming videos, we will go deep into software architecture and understand more aspects of this. Thank you for your valuable time.